Alright, so we're on to the next TIA portal lesson example. I think last week we worked on manual control for the clamp and the gate here and the emitter. Might be a couple weeks. Now we want to, I think we were going to write some manual control for, or the semi-automatic control for the conveyor. So let's open up our project. I guess we can go online too. Yeah, it's a trusted. So we're gonna create one that's called add new block. It's an FB. And it's going to be called Conveyor Control. Excuse me. And let's see. Let's do it kind of similar like to our other ones, our clamp control and stuff. We don't really maybe actuator control. Yeah. We don't really have a work position and a home position, but we would have a command and we would have an output and then we would have a step. So command and we're putting that as an in-out because we're going to accept a command and say if it's like 1 is going to, I'm trying to do it across this whole machine, a 1 command is home. If we get a 1, we turn off our outputs. Well, we try to get our actuator back into a home position, then turn off our outputs. With the conveyor, all there you can do, as far as I can think of, is just turn the conveyor off. Maybe a person might run the parts out, but that's kind of needs to work as a whole station because you have other parts. The gates need to be in the right place and all that. So we've got a command, and then we might have a conveyor output, and that's going to be a bool. And I'll see if we need to tweak that, if that can be just an output or, you know, something like that. Okay, so we have a case statement. And remember a case statement, it looks for this thing, which like we're going to put in here, command. And then it's going to say, you know, if it's a 1, do this. And this means 2, 3, or 4. You know, 2 through 4, then it would do this. If you had commas, then it would be ors, 2 or 4. So case of command, and then I like putting the constants in here. We're definitely going to have a command done, a home command, and then I was thinking we would have a command to run a part basically to where we stop at this sensor here. We're actually going to have it stop past this sensor here, but we're just going to have run to position 1 and run to position 2 is how we're going to think of it. When whatever data, whatever value we push in will be dependent on those. We could have it stop like once it meets, like the part would it'd stop right here. We could have it stop here. We could have it hit stop and run so long, or break the sensor and run so long. So, but we're just going to say, if you get to position 1, then you stop. Or if you give it this other command, you go to position 2. And I might, instead of saying position 1, position 2, I might say in feed or out feed. So home command, run part to in feed command, and then run part to out feed command. Okay. Oh, if you double click up here, see that? You can drag like that, but if you double click, it'll automatically size that for you. Just a little hint. Okay, so command done, I'm going to say it's always a 0. Home command, I'm always going to make a 1. I tried to make my manual commands to be in the tens place, like over here it's 10 and 11. And then my home situation, had a 1 in the back, and then my auto commands had a 2. So, but the conveyor doesn't really have that. I guess we could have a jog feature. Let's add that in. Add row, jog command int, and that is now, because that's in our work position and it's a manual command, I'm going to make it a 12. A person needs to, when you build a new machine, to document this stuff pretty thoroughly. That way you can have consistent numbering for like your commands and stuff like that. Run part to in feed command, I'm going to make that a 22, and run part to out feed, I'm going to make that a let's make that a 32. I guess it could be a 23. That's where like a person needs to define their spec. Let's make it a 23 because I don't have any other. We'll only ever have one auto return to home command, but we could have several auto move to work position commands. So maybe that's my thinking of that. So in case of command done, and then we don't really do anything, what about in case of home command? Let's put our command numbers in here too. So if we get that, then we are going to write conveyor output is definitely going to be false in that instance. And then else we have an unknown command. Oh yeah, I wanted to write it false, and then command is going to, we're going to assign it the value of command done. So what does this mean? This means that if you shove a 1 in here, we're going to turn off that conveyor, and then we are going to also change that 1 back to a 0. I got to thinking about it later, and again, documentation. Maybe actually a person would want to set that command to 99 or something like that, as the done. But we'll work with that. Else we have an unknown command. Well, if we have an unknown command, we want to reset or try to fix our command again. Okay. So let's shrink the, adjust these a little bit. So if somebody gives you a jog command, they give you a 12. Let's do that. Okay. Oh, the editing is getting, there we go. Okay, so somebody gives us a jog command 12. We're going to write our conveyor output true. And then we're just going to wait. I guess we probably need to backtrack. I'm getting ahead of myself. We also we ought to have, I think it'll come back to bite us. Jog command, let's do a stop command. And that'll be an 11, because that's a manual command, and we're telling it to turn off its outputs or return to the home position. So, stop command. And that is basically just this again. Okay, now if we do run part to infeed command, let me get my syntax right. Okay, and that is command 22. Let's see, then we are going to have, basically we're going to run it until we get to an infeed sensor. So let me do this. We could say conveyor output, but I don't, maybe for the most simplistic sake, we're going to say conveyor output equals not infeed sensor. Yeah, okay. And then if we have run part to outfeed command, command 23, so we could do some testing on that. You know, so somebody gives it a 22, we don't have the infeed sensor met, our conveyor output's going to run. Oh, we need a way and escape to get out of it. If infeed sensor, then command, we probably command assign, command done, end if. And we can almost copy this straight up again. But we're going to say the outfeed sensor okay. So let's compile that. I don't think we'll find any errors in that. Does this make sense? The conveyor output will be not outfeed sensor. So until you have a part at the outfeed sensor, the conveyor is going to be on. Once you get a part at the outfeed sensor, the command is going to go back to 0. So then it'll turn that off. I guess we could turn our conveyor off too. That might be a good idea, because otherwise we won't be looking at it again. And I guess in an unknown command we might turn off our output also. Okay. Alright, so now I need to make the actual call to this. Let's save it too. So, Station 1 actuator control. Now I'm going to pack into here right behind emitter control instance, conveyor control. Going to be a multi-instance. And we are going to have an in-feed sensor, an out-feed sensor. I wonder, I thought I'd written a data type that had Station 1 inputs. Oh yeah, might be able to use that. That would make things clean up a little bit. Yeah, let's do that. Station 1. Oh, let's just call it position data. Data type Station 1 position data. And we're going to take these out. It's going to break everything for a second, but we'll fix it. So in-feed leaving is going to get piped into there. And then clamp is going to get piped into there. Gate is going to get piped into there. And outfeed leaving is going to get piped back into here. See, and then we just got this one to manage on the interface. And we actually ought to write a, it'd be nice to have a data type that was like Station 1 commands, and maybe a data type that was Station 1 outputs. But we can get there in time. It's going to drive me crazy. I want my conveyor control to be, I like to have the stuff in my calls in the order that that stuff is called. Emitter command, emitter output. I hit my caps lock. Conveyor command. And that's a data type int. Then we got conveyor output, and that's a bool. So let's put conveyor command needs to go into there, and conveyor output needs to go into here. Yeah. Alright. Now, if I go to my OB where that's called, and that's going to be a wreck, but we can fix that. We want to update block call. Did I still? Nah, we can try to fix it like this. Let's just do this. Yeah, let me undo that. I think I need to compile this one first, maybe. Did I compile that? Yeah. Did I still leave the clamp position data and gate position data in there? I don't think I did. Okay, well, we can do this. Station 1 DB position status. That'll get plugged into there. Oh, and then I need to add my add row. We need a conveyor. Might make these writable from the HMI. We might undo that, you know, because we might want manual control from the HMI. Okay, then I need to put this output in there. I wonder what the hang up is there that I've done. I need to get rid of those two. The formal parameter isn't found. Well, I need to update that. I wonder if I can do a compile all and that'll fix that. Compile software, rebuild all. For the life of me, I cannot think of why I got that hung up right now. Well, maybe I can. I don't think I can delete it and plug it all back in. Yeah. I wonder if it'll let me do that. Yeah, okay, so let's save and download. Stop modules. Why are they stopped? Huh, I've never seen that before. We're still running. Okay, well, let's go to, yeah, we got our DB handy. We are online with it. We've got this thing active. So what did we need to do to make a part? We needed to plug in 12. Okay, we made a part. Perfect. What do I need to do to make that gate go up? I need to give it a 12, maybe? No, that's a clamp, dang it. Give it 11, the gate. Okay. Now, if I tell this conveyor, let's give it a, no, let's give it a 12. It should jog continuously, right? And if I give it an 11, yep, and then it stopped. Oh, there we go. There's one hang up. Oh, I'm not telling it, I don't necessarily, I'll have to do some thinking about that. I don't necessarily want to write this back to 0. Maybe if you tell it to stop, you might, but if you're telling it to jog, you don't really want to tell it to write to 0. So let's maybe change that. Conveyor control instance, open and monitor. If we give it a stop command, conveyor output equals false, and command equals command done. Okay. So if I give this thing a 12 again, I can make a new part. Okay. And then if I tell it to go to 11, no, I want to tell it maybe to go to 22. It ought to run the part to the first. Okay. And then if I give it a 23, it should run past that part leaving and then turn off. Okay. And I think her debounce gives it the little bit of time that it scooted past that. So now I should be able to feed another part in. Yeah. And then I should be able to tell it to go to 23 again, and it should feed all the way down to there. Conveyor 23. Yeah, okay. And then we wrote back to 0. And if I, let me turn this up. If I force the conveyor on with like a 12, I can give it an 11 to stop it. Yeah. Or if I give it a 12, I can give it a 1 to stop it. The idea with giving it the 1s is that in your home sequence you would, you just write a home to everything. So let me home everything up while we're at it. And then maybe we'll run through the sequence once, and then we'll go from there. Okay, so I'm going to feed a part, right? And then I'm going to run until we get past there, which was 22. Okay, then I'm going to clamp, which is a 12. Okay, and then I'm going to release, which is an 11. And then this thing's going to come over and set the part on. We're going to wait. Once we're done waiting, then the gate's going to go up. And then we are going to give it a 23. Conveyor gets a 23 because we're going to run this part out. Okay. The gate's going to come back down. Yep, and then we're good to go and ready for the next part. So we need to write the sequence, but we have all the manual controls done to do this station. And this station even has less stuff for the manual controls. Like, that'll nearly be a copy and paste. I probably won't do the video on that, you know, where it'll just be done. And then we've got this gantry crane thingy here, and interfacing the control box with it, you know, and that'll be about our SCL tutorial. So we're getting quite a bit closer. Hope you learned a lot from the video. If you got suggestions, if you know what that hang-up was, that'd be cool. I wouldn't mind. I could definitely learn and get the insight on that. But thank you guys, gals, everyone, for watching. Hope you enjoyed the video. Okay, bye.